Muhammad Hassan, and my project is design and implementation of selective laser sintering. My group members are Varisha and Hassan Hafiz. I am very thankful to my supervisor Dr. Sayyid Zahul Hussain and co-supervisor Engineer Ghazi Hamza. Now let me introduce you to AM. Additive manufacturing is the process of creating an object by building it one layer at a time. In additive manufacturing, we are focusing on powder bed manufacturing. And in powder bed manufacturing, we are focusing on SLS. Here the steps that follow SLS printer. SLS powder is sintered to produce parts. The steps include G code is uploaded, spreader is used to spread the raw material on the bed. After spreader laser is achieved, the product is completed here. Feed tank is up and bull tank is down. So our product that is finally formed is here. Literature review. Lan S. Kinslinger. Here title is Open Source Selective Centering. In two, 2016, Yang Wang, his objective nanofillers to enhance SLS technology. And his title Selective Laser Centering and Behavior of the Polymer Powder. He represent in 2017. Ionis Age Huge. His objective is different types of laser technologies used in SLS 3D printer. His title Selective Laser Centering, a new chapter in production of solid oral forms by 3D printer. He works in 2021. Amir Mehyar, his objective recently developed SLS 3D printer and their feasibility. His title Review of Technological Improvement in Laser-Based Powder Bed Fusion of the Metal Printer. He works in 2020. Now I invite to my colleague Hassan Hafiz for problem statement and object.
Assalamu alaikum. My name is Hassan Hafiz. Today we discuss about the objective of selective laser sintering printing 3D printer. The objective is design and fabrication of selective laser sintering 3D printer that democratize access to selective manufacturing 3D printer. We add IoT. Assalamu alaikum. My name is Hassan Hafiz. Today we discuss about the objective of selective laser 3D printer. The objective is design and fabrication of selective laser 3D printer that democratize access to design additive manufacturing technology. Our problem statement to add a IoT based monitoring system in which ESP scam is used to help us demo- democratize the live manufacturing of our part. Now allow me to discuss about the SDGs. 4, 9 and 12 SDGs suitable for according to our selective laser 3D F5P project. In 4, quality education, our aim to build a low cost 3D printer that help the student to learn how 3D printer can work. In 9 SDG, the industry used as use select SLS 3D printer to build complex geometry part to perform it. The 12 response, composition, and reproduction. We decided to recycle the powder to build another part. Now allow me to discuss about the product specification. Design of parameter, the according to our suggestion, the external size is 50 by 50 centimeter. The print bed size is 20 by 20 centimeter. The laser which we are using blue light diode with 40 watt. The powder we are using to build a part nylon PA12. The gantry core XY is used to build a selective laser 3D printer. Now I call our colleague Varsha to discuss about further.
Assalamu alaikum. My name is Varish, and today I'm going to discuss about the block diagram of a selective laser sintering 3D printer. Uh, Let's start with the microcontroller that is being used in this selective laser 3D printer. It is the Arduino Mega 2560. Uh, we can use any Arduino based microcontroller or a Raspberry Pi for this because the software that we are using is Marlin and it allows for that. In this block diagram, as you can see, a power supply is connected to a emergency stop, which is then connected to this CNC shield. It is providing the uh, required amount of power to the CNC shield to work, which is then being transferred to the Arduino uh, at 5 volts for the Arduino to work. A slicer software then generates a G code, which is then sent to the Arduino Mega. The Arduino Mega then activates and sends the CNC's CNC the commands, which is then transferred to the motors. As you can see, we have 5 motors which are connected to the X1, Y1. These are the gantry control motors. There are powder bed control motors, the Z1 and Z2, and the X2, a spreader controlling motor. Further, we also have limit switches for X and Y direction, and there is also a laser connected to the emergency stop and the Arduino Mega. The Arduino Mega provides the laser with the duty cycle and lets it work. Now let's focus on the cost analysis and work distribution. This is a general cost and the future that we have decided to work on. The general cost that we have decided to work on is 1,40,100 rupees. But this is an estimated cost. It can be more than around, it can be more, and we have a budget of 2 lakh rupees. The timeline of the project, according to this